from Fresnel's equation, we have R parallel equals to tan of theta I minus theta t by tan of theta I plus theta t. Then if R parallel equals to 0 for theta I plus theta t equals to pi by 2, then the electric field polarized parallel to the plane of incidence is not reflected at all. Then R perpendicular equals to minus sine of theta I minus theta t by 1. Sine of theta I plus theta t is sine pi by 2. It is non-zero. That is, the electric field polarized normal to the plane of incidence is partly reflected because it is non-zero. So an unpolarized light consists of both type of electric field. That is the parallel to the plane of incidence and also perpendicular to the plane of incidence. If it incidents at a particular incident angle theta I equals to theta p and satisfying the relation theta p plus theta t equals to pi by 2, will give the plane polarized light, plane polarized electromagnetic wave normal to the plane of incidence. This angle of incidence theta p is known as the Brewster's angle or angle of polarization, for which R parallel equals to 0. That is, it is called a plane polarized light normal to the plane of incidence. Now the Snell's law becomes Nt by Ni, that is the medium 2 by medium 1, refractive index of medium 2 by medium 1 is sine of theta I by sine of theta t, that is equals to sine theta p by sine of pi by 2 minus theta p, that is tan theta p. So we get the relative refractive index is equals to tan theta p, that is the tangent of the angle of polarization is equal to the relative refractive index. This is called the Brewster's law. Total internal reflection. When the incident medium is more dense, that is Ni is greater than Nt, in that case theta t is greater than theta I. Then R perpendicular shows the positive value, and if we put theta I equals to 0, then it starts from the value Ni minus Nt by Ni plus Nt and increases as the theta I increases and attains the maximum value of plus 1 for theta I equals to theta c. This theta c is called the critical angle. It is the angle of incidence for which the angle of refraction is 90 degree. Similarly, the R parallel term starts from minus of Ni minus Nt by Ni plus Nt at theta equals to 0 and passes through 0 at theta I equals to theta p, that is the angle of polarization, and also increases up to plus 1 at theta I equals to theta c. It can be shown graphically. This is plus 1, this is minus 1. This is the angle theta p and this is the angle theta c. This is the theta degree, and along the y-axis amplitude coefficients. Now the critical angle theta c by Sren's law is given as sine theta c by sine pi by 2 is equals to nt by ni, and this ratio is taken as n, then n sine this ratio is taken as 1 by n, and then n sine theta c equals to 1. For any other theta I, we can get sine theta t equals to n sine theta I. Now for theta greater than theta c, that is the angle of incidence greater than the critical angle, n sine theta I is greater than 1, and cos theta t equals to root over 1 minus sine square theta t shows the imaginary term. And when these values are put into the expression of r perpendicular and r parallel, then both of these two expressions shows imaginary terms, that is the complex numbers, but the modulus r perpendicular equals to r parallel equals to 1. That is, the electric field has two components. One is parallel to the plane of incidence and another is perpendicular to the plane of incidence. Both electric field totally reflects back. This is the total internal reflection.